Hello and welcome to Foundations for Algebra, Unit 1B, Lesson 2. Today's objective, remember you should be filling in your notes as we go. Today's objective is that scholars will compare proportional relationships. So, how could we compare two proportional relationships? So the constant of proportionality, the COP, is also called the slope or rate of change, okay? So we've learned how to find slope and rate of change so we can compare these. So let's look at this. When we have two items that are represented in the same way, as you can see, brand A is this lovely line right here. Brand B is this yellow line right here. How can we compare them? Well, that's actually pretty simple. We are going to compare the steepness of the line. Remember, the steeper a line is, the closer it is to vertical, straight up and down. Steepness of the line. So in this case, I can tell that brand A has a greater slope, rate of change, COP, whichever you want to say. It is changing faster. In this case, since we're talking about cost, that means it is more expensive. So I know that brand A is more expensive because the line, if we look at the line, brand A's line is steeper. It's moving up faster than brand B. That means the rate of change, or the slope, must be greater for brand A. And remember, our rate of change for a proportion is our unit rate. It is how much each one costs. So let's look at what happens when we're comparing ones that are not represented the same. So we're still comparing proportions, but in this case, car A is a verbal description. So this is one of the ways that we can represent them. This is a verbal description. Verbal just means words. So this is a verbal description. That just means words, okay? And car B, we have a graph. So for car B, we have this lovely graph. Now, we've seen these before. We've talked about them. So how can we compare them? Well, usually the easiest thing to do is put them in the same format. So we're going to put them in the same format. So we could make car B's into a verbal description, in which case we could write this in green. Let's see, car B traveled, if I look at in 6 hours, car B traveled 300 miles. So I could write that in 6 hours, car B travels 300 miles. Now we can tell which one's going faster. We can tell it's car A because it went 330 miles. The other thing we could do is we could graph car A. Since this is a proportional relationship, I know it's going to start at 0, so I can put a point at 0. And I can put a point at 6 hours and 3:30. So I would go over to 6 hours and go up to where 3:30 would be. So I can put a dot right about there. It's a little over halfway. And then I could connect them and make a line. See how good my line is. It's not going to be perfectly straight because I'm drawing freehand. But you can see that that line is steeper. They both start at the same point, and this one's going up quicker. So you're just going to put them into the same format. Well, what happens if I have three different situations, three different things? So here I have, and you guys have seen this before, remember the sedans, the trucks, and the SUVs. Remember what we did. and this is what you can do on your notes. We're going to put everything onto the graph. So first I'm going to put the blue, this blue one on. So in that case, I know we have the point 0, 0. I'm going to put that point there. Then I know that it takes 22 hours to build one, so 20 and 44 hours, so that would be like right here to build two. So I can put a dot there. And I know that it takes 66 hours to build 3, 88 hours to build 4. So I can connect all those points. And that is the line for my trucks. So we can see that it's steeper. I can also do a line for my SUVs, and I'll do that one in red. So this, remember, was the SUVs. Okay, so that line, again, I know I have 130, so I come over to 30 and go up to 1 and put a point there. And remember, I also know that I start at 1, or at 0. I can go to 60 and put a dot at 2, 90 and put a dot at 3. So I can see that when I connect those dots, that line is going to have a less steep slope. So once again, I compared them. I've got all of them, so I can tell that the trucks, the blue line has the greatest rate of change. In this case, remember, it is how quickly they are building vehicles. Rate of change, where rate of change, slope, and constant proportionality are all the same for proportions. Rate of change and slope are always interchangeable, but when we go through the origin, 0, 0, it is also proportion. So, make sure that you've completed your notes and then go on to your Mobius math. I'll see you in class.